Bringing nature home. Ladies and gentlemen, what a great honor it is to bring Dr. Douglas Tallamy back to our home in Rhode Island. Dr. Tallamy is a distinguished professor at the University of Delaware who has performed groundbreaking work in the fields of entomology, biodiversity, sustainable gardening that have earned him national acclaim. He's a true translational scientist who takes observations from the laboratory and from scientific studies and from our surroundings and gives us real interventions to improve the health of our environment and of humanity. Dr. Tallamy has a passion for understanding the ecological impact of non-native plants on biodiversity and has emerged as a guru of conservation. Today's talk promises to shed light on urgent environmental issues and will inspire us to action, to teach us how to make changes in our homes and in our communities. For most of you who know his work, you know he has started a grassroots movement that may even mean pulling up our own grass and planting roots of native plants. Dr. Tallamy's academic journey has been relentless, and his numerous scientific publications attest to his being a scholar, a teacher, a mentor to many, a humanist, and a real inspiration to all who are concerned about our world. In his seminal works, Bringing Nature Home, The Nature of Oaks, and Nature's Best Hope, Dr. Tallamy has courageously challenged conventional wisdom and has tenaciously fought to teach us the importance of how native plant species maintain our ecosystems. In teaching us about the intricate relationships between plants and insects, he illuminates the path toward a more sustainable future for all species. His Homegrown National Park initiative underscores his dedication to fostering a greener, more biodiverse, and healthier planet. Let us embrace his vision for a better world where native plants flourish, where biodiversity thrives, and every individual contributes to nurturing our great national heritage. Nature's best hope is humanity's best hope, is our best hope for a greener, sustainable future. Please join me in welcoming a true friend of nature, a true pioneer, Dr. Douglas Tallamy.
Okay, thank you. It is wonderful to be here. We're a little behind schedule, so I'm just going to jump to the chase here. You are nature's best hope. Any questions? All right, I'll tell you why I think you're nature's best hope. We're lowering the lights. You'll be able to see this in a minute here, but yeah, that's what the talk's about. Really, why I think you are nature's best hope. But before let's talk about what E.O. Wilson's idea of nature's best hope was. The late E.O. Wilson. He died the day after Christmas 2 years ago. Tremendous loss to the world of conservation. But one thing that was consistent throughout his very long career was his love of life on planet Earth and his efforts to save it. And he wanted to save it not just because he loved it, but because he knew it was essential to our own survival. So in 2016, he wrote this book, Half Earth, Our Planet's Fight for Life, and he had one simple message. If we don't save nature, if we don't save functioning ecosystems on at least half of the planet, it's going to disappear over the entire planet. And that includes humans. Very bold message. He spent most of the book talking about the science that supports that very bold message. And then he ended the book. He didn't spend a lot of time telling us how we were going to save nature on half of planet Earth. Of course, to a conservation biologist, that's a great idea. We'll just put half the Earth aside and everything that's in trouble can be in that half and we'll be in the other half. And it'll be great. Problem is half of terrestrial Earth, some form of agriculture, half of the Earth in some form of agriculture. And we've got 8 billion people and all of our detritus and all of our roadways and airports in the other half. And we don't have a third half to put aside for nature. So how can we realize E.O. Wilson's dream? That's really what I want to talk about today. I think we can. But we need a new approach to conservation to do that. Before we talk about that, though, let's talk about what happened in 2019. And then again this year, we had a very large oak mast Members of the red oak group got together and decided to make their acorns at the same time, and that's what it looked like in a lot of places. I'm easily entertained. And I just took one of those acorns and I stared at it. But I was rewarded because an insect started to chew its way out of the acorn. First, it chewed a little hole for its head, then it forced its head through there, then it forced its entire body through that hole. It was a tight squeeze. And once it's out of the acorn, it's a dangerous time for this insect larva because it's good to eat. A lot of things are after it. So it gets to safety by wiggling and squirming beneath the soil surface. That takes about 30 seconds. And once it's underground, it stretches in all directions and forms a chamber. And within that chamber, it converts itself to a pupa. And then surprisingly stays in that underground chamber as a pupa for 2 years. After 2 years, comes out as an acorn weevil. That's what an acorn weevil looks like. A lot of people think weevils have big noses, but that's actually an extension of the head capsule. And their mouth parts are way down there at the end of that extension. They take those mouth parts and they chew a hole into the center of the acorn, turn around and lay an egg in that hole, and that is how the larva gets into the acorn. Why do they spend 2 years underground instead of coming out the next year the way most insects would? Well, it takes red oak acorns 18 months to complete their development. So if they came out the next year, there wouldn't be enough acorns for it. Of course, after they leave the acorn, it leaves a hole, kind of like a true vacuum. You know that nature abhors a vacuum. And in this case, she filled it with 3 species of temnothorax ants, tiny little ants where the entire colony lives in the holes made by acorn weevils after they have left the acorn. And if scouts find a new hole in a new acorn, they get all excited because their old acorn is falling apart. So they tell everybody it's time to move. Grab the larvae, grab the eggs, move the entire colony into the new acorn. That takes about 30 minutes. And once they're inside, they post a guard to make sure nobody else comes in. And that's where they'll live for the next 2 years until that acorn falls apart. What's my point with this little story? That's just one of literally millions of very specialized interactions, largely between animals and plants, that comprise the bulk of nature. This is another one, the relationship between jays and acorns. Jays are the primary disperser of oak acorns. They'll take an acorn, fly up to a mile from the parent tree, tap it below the surface of the soil, and the object is they're going to go back in the wintertime and have something to eat. But for every 4 acorns they bury, they only remember where one is. So for every 4 acorns they bury, they've actually planted 3 oak trees. And a single jay can bury 4,500 acorns each fall. Specialized relationship between pileated woodpeckers and carpenter ants. That's what they rear their young on, carpenter ants. So you won't have a lot of pileated woodpeckers unless you have a lot of carpenter ants, and you won't have carpenter ants unless you have the big trees that make those carpenter ants. You won't have this bee, Andrena facilii, unless you have this plant, Facilia. That is the only pollen that bee can rear its young on. And it turns out that pollen specialization is very common in our native bees. We've got between 3,600 and 4,000 species of native bees, and over a third of them can only reproduce in the pollen of particular plants. You won't have the Baltimore checker spot unless you have white turtlehead. I could talk all day, all week, all year about nature's specialized relationships. But the point I want to make this morning is that actually most of these relationships these days, nature itself is on the ropes. And it's on the ropes because we didn't take Teddy Roosevelt's advice. Way back in 1908, Teddy heard that the state of Arizona was going to mine the Grand Canyon. So he went to the canyon, looked out over the edge, and he said, leave it as it is. And with those 5 words, he started the process of creating the Grand Canyon National Park. But we didn't leave most of the country, particularly the lower 48 states, as it was. There's only about 5% of the country that's anything close to its original pristine ecological condition. And those areas are typically mountaintops. And that's because we have logged the country repeatedly. We have tilled it. We have drained it. We have grazed it. 770 million acres of rangeland out there. That's 4.5 times the size of Texas, dedicated to cattle. And of course, we've paved it or otherwise developed it. We have straightened our rivers and dammed them. You can spell that any way you want. We have polluted our skies and changed our climate for centuries to come. We've drained our aquifers. We've introduced more than 3,300 species of plants from other continents, many of which are running amok in our natural areas. In short, we've carved up those natural areas into tiny remnants of their former selves. And each one of those remnants is too small and too isolated to sustain the amount of nature that we humans need. Because remember, it is nature that keeps us alive on this planet. So why have we done this? I don't know. But I suspect we thought that our nest, planet Earth, was so large we could foul it forever and there wouldn't be any consequences. And of course, we were wrong about that. And that's why we're seeing some pretty serious headlines these days, like the insect apocalypse is here. What does it mean for the rest of life on Earth? Talking about global insect decline. By the way, this one, you know this one. North America's lost 3 billion breeding birds in the last 50 years. That's a third of our North American bird population already gone. Now, the UN's predicting we're going to lose 1 million species to extinction in the next 20 years. And they said it 2 years ago, so I guess it's the next 18 years now. This is a prediction, but it's one we have to make sure it does not come to pass, because those are the species that keep us alive on this planet. Serious stuff. So I could go on talking about the pox that we humans have delivered upon the environment, and as Shakespeare would say, upon all of our houses. That's not what this talks about. This talks about a cure for that pox. It's a cure that'll take small efforts from lots of people like you and me, but those efforts will deliver enormous physical, psychological, and environmental benefits to everybody. Edwin Wade Teal decades ago said, we cannot make the world uninhabitable for other forms of life and have it habitable for ourselves. This is just common sense, and I guess it's so common sense we can't see it. All right, let's return briefly to this headline. The insect apocalypse is here. What does it mean for the rest of life on Earth? Back to E.O. Wilson. He told us what would happen if Earth lost its insects, and he did it way back in 1987 with this paper, The Little Things That Run the World. And again, his message was very clear. Life as we know it depends on insects. And if they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappeared, that would so drastically change energy flow through our terrestrial ecosystems that the food webs that support our vertebrate animals would collapse. Our amphibians, our reptiles, our birds, and our mammals would all disappear. The biosphere, the living portion of the Earth, would rot because it would have lost insect decomposers that rapidly turn over nutrients. All we would have is bacteria and fungi. And again, humans wouldn't survive any of those drastic changes. There is some good news, and that is that none of that has to happen. We can save our insects, we can save our birds, we can save nature itself, but we are going to have to change the way we landscape to do it. Why is that? Well, remember, humans are products of nature. We are totally dependent on the life support that ecosystems provide. Top grouping there is just some of the things that plants do every day that we depend on every day, like produce oxygen, like clean our water, slow its journey to the sea where it becomes too salty to use. Carbon capture, enormously important today. Plants, of course, build their tissues out of the carbon they take from carbon dioxide, remove it from harm's way through photosynthesis, and they fix more carbon than they can use, so they actually pump the extra carbon into the ground through their root systems. And once it's in the ground, it's extremely stable. Plants are building topsoil. They're holding it in place. They're preventing floods. They're dampening severe weather. They're converting sunlight into food. If we lose plants, we're going to have to eat sunlight. And then we will lose weight. What do animals do for plants? They provide pest control services. They pollinate nearly 90% of our flowering plants. They disperse plant seeds. So designing landscapes like this that destroy the production of ecosystem services is just not a good idea. Never was a good idea, but today it's a terrible idea because of those 8 billion people demanding more and more ecosystem services every day. Now, we do have parks and we do have preserves, and they're doing the best they can, but we are in the 6th great extinction event that the planet has ever experienced, which means it's not good enough. So I think the solution is to start practicing conservation outside of parks and preserves on landscapes just like that. Now, there have been visionaries through the ages who recognized that we humans needed to work on our relationship with planet Earth, and Aldo Leopold was one of the most eloquent. He wrote extensively in the first half of the 1900s. One of the things he said is the oldest task in human history is to live in a piece of land without spoiling it. Now, there have been indigenous groups who have been good at doing that. But our huge Western societies and our huge Asian societies are terrible at doing that. We habitually take more from the earth than it has to offer, completely wrecking an area, going to another area, doing the same thing, not sustainable behavior. But Aldo Leopold had a lot of faith in humans. He believed we were capable of developing what he called a land ethic. He knew we had to use the land. We had to farm and lumber and graze and mine and do all of those things. but he believed we could learn to do them gently enough that we did not destroy local ecosystems. That's what he called land ethic, and he wrote about it in the Sand County Almanac, his most famous book. What he did not write about was developing a land ethic where we lived. And I'm not sure why that was, but I suspect the notion that humans and nature cannot live together. We cannot coexist in the same place at the same time. That notion was so deeply embedded in the culture of Aldo Leopold's day, it still remains in our own culture. He may not have recognized it as an option. Well, what I want to argue this morning is that not only is living with nature an option, it's now the only viable option that's left to us. In the past, of course, conservationists worked pretty much exclusively where there weren't a lot of people. We now need to turn that on its head and practice conservation where there are a lot of people, because that's pretty much everywhere. And that means we've got to find ways for nature to thrive in human-dominated landscapes. Not hang on by a thread, but thrive. Where should we start? Well, back to private property. Most of the country, particularly the lower 48 states, is privately owned. 78% is privately owned. 85.6% east of the Mississippi is privately owned. If we don't practice conservation on private property, we're going to fail. And failure is not an option. Now, when I use the word conservation, I'm not using it exactly the way I mean. We do want to conserve any bits of nature that are left out there. That's been our conservation model for the last century. And we want to keep doing that, even though there's less and less that is left. But it's not good enough. It's not good enough. So we have to go beyond conservation into restoration. We have to rebuild nature in so many of those places that we've dismantled her. And people will say, well, there's no way you're going to put it back together again exactly the way it was. And they're probably right. We've changed too many things. But we can reunite enough of those specialized interactions that I opened the talk with to recreate ecosystem function once again. That's what we're going for, ecosystem function, even if it's not exactly what was on a particular space at some point in the past. But to do that, we have to start with the building blocks. Not all species contribute to ecosystem function equally, so we have to start with the most powerful groups. And there's two groups we can't do without. One is the flowering plants. And of course, the pollinators allow those plants to reproduce. They are capturing energy from the sun and through photosynthesis, turning it into food, into simple sugars and carbohydrates, which is the food that supports just about all the animals on the planet. So now we have the food that animals need stored in plants, mostly plant leaves. Well, it turns out that most vertebrates don't eat plants directly. Most vertebrates eat invertebrates that eat plants. Most of those invertebrates are insects, and not just any insect. Caterpillars turn out to be enormously important. They are transferring more energy from plants to other animals than any other type of plant eater. So if we design landscapes that don't have a lot of caterpillars in them, we're going to have failed food webs and eventually failed ecosystems. I'm going to use the Carolina chickadee as an example. That is the chickadee that is at my feeder right now as we speak. I live in Southeast Pennsylvania. You know, you guys have black-capped chickadee, practically the same bird doing the same thing. And we tend to think, because they're at our feeders all winter long, that that's all they need is seeds. Well, even in the wintertime, only 50% of their diet is seeds. The other 50% is insects and spiders, even in the wintertime. And when it comes time to reproduce, their babies can't eat seeds at all. And that is typical. Most baby birds cannot eat seeds. So the chickadees switch to invertebrates, and if they're in a healthy environment, they will rear their young exclusively on caterpillars, and they are not alone. 96% of our terrestrial birds rear their young on insects, and most of those insects are caterpillars. So there's something special about caterpillars. What is it? There's actually several things special about caterpillars, and the first one is that they're soft. Think of this guy as if he's a little sausage with a very thin wrapper. The thin wrapper is exoskeleton. It's made of chitin. It's undigestible. And because they're soft, you can stuff them down the throat of your offspring without fear of injuring them. If you've ever watched a parent bird rear their young, they're pretty rough. It's like a plunger. They just stuff it down there. Caterpillars are also relatively large prey items. One medium-sized caterpillar is equal to the biomass of 200 aphids. Now, some of our birds do chase aphids around, but you want to chase 200 aphids, you get one caterpillar. They are nutritious. They're high in fat, high in protein, low percentage of chitin of exoskeleton compared to many other insects. Whoops. Yeah. Particularly beetles. Beetles are not like little sausages. They're like little tanks. So much of a beetle is undigestible, and a lot of beetles have really sharp edges too. And it turns out that caterpillars are the best source of carotenoids for birds during the breeding season. I mentioned carotenoids not because I love organic chemistry. I don't. But because I'm a vertebrate, and you're a vertebrate, and birds are vertebrates, and we vertebrates cannot make our own carotenoids. Only plants make carotenoids. So we have to get our carotenoids from plants. And we have to get them from plants because carotenoids are essential components of vertebrate diets. Where are the birds getting their carotenoids from, particularly during the breeding season? Well, from those prey items they're bringing back to the nest. But look, carotenoid content is not equally distributed among bird prey. Those two bars all the way over on your left are caterpillars. They have far more carotenoids than other types of bird prey. And butterfly down there, that's the adult caterpillars, the moths and butterflies themselves. They have far fewer carotenoids because they're not eating the green leaves. That's where the carotenoids are. And way over here on the right is the earthworm. So the early bird gets the worm, but he doesn't get any carotenoids when he gets the worm. And there's a very tight correlation between how often a prey item is brought back to the nest and its carotenoid content. Caterpillars are brought back more often than anything else, and they have the highest carotenoid content, followed by orthopterids, things like grasshoppers and crickets, and then everybody else is nestled down in the bottom there. So these studies are suggesting that caterpillars are not optional parts of bird diets. They are essential parts of most bird diets. So let's just say most birds need caterpillars. The next question is, how many caterpillars do they need? Is one or two enough? Oh, come back here. My fingers keep touching things. Is one or two a day enough? No. It takes thousands of caterpillars to get one clutch of Carolina chickadee to the point where they leave the nest. And that depends on the number of chicks in the nest. And after they leave the nest, the parents continue to feed them caterpillars another 21 days. But they're flying all around, so nobody's been able to count those. But you're really talking about tens of thousands of caterpillars that are required to get a bird that's a third of an ounce to independence. And of course, after they're independent from the parents, they keep eating caterpillars. And if you want chickadees to breed in your yard, and I would think you do, because in so many places that's all we have, you have to have all those caterpillars in your yard because they only forage about 50 meters from the nest. And again, that's true for most of the birds that are out there. They're not flying 5 miles down the road to the nearest woodlot. They're staying very close to the nest. And if we landscape in a way that does not include all of those caterpillars, that's called insect decline. And it's really looking like insect decline is one of the major causes of the bird declines that people are measuring. We went to the original data set of Rosenberg et al., the Smithsonian group that said we've lost 3 billion breeding birds in the last 50 years. And we divided the terrestrial bird species into two groups. The species that require insects, that big bar, particularly when they're breeding, and the species that do not require insects. So things like doves and finches and crossbills can actually make a little milk out of the seeds that they eat, and that's what they rear their young on. And look, the species that do not require insects didn't lose any numbers at all in the last 50 years, but the species that require insects lost on average 10 million individuals per species. This does not prove cause and effect, but it does suggest that as you take bird food away, you lose the birds. Look, it's not just tiny birds that need insects. This is a kestrel eating a white-lined sphinx, and it's not just birds. This is a ornate box turtle. Used to be common in the Midwest, eating a caterpillar. They love caterpillars. They would chase armyworms and cutworm outbreaks around and eat hundreds of caterpillars a day. So I think we need to raise the bar about what we're asking our landscapes to do. In the past, we've asked them to do one thing, be pretty. Now we're going to ask them to do two things, be pretty and ecologically functional at the same time. And that's not going to happen unless you put those caterpillars back. So how do you add caterpillars to landscapes? Well, you put the plants that support those caterpillars into your landscape. Seems pretty straightforward, but there is a catch, and that is that most plants do not support a lot of caterpillars. So we have to be fussy about it. We have to be fussy about which plants we choose for our landscapes, and we have to be fussy about it because the caterpillars themselves are fussy about it. You can have all the breadfruit pear and all the ginkgos and all the hostas and all the burning bush and all the privet and all the barberry, all the things we typically landscape with in your yard, and you won't make a single monarch butterfly. The only thing that's going to make a monarch butterfly is one of the milkweeds. That's called host plant specialization. And it turns out that most of the insects that eat plants are host plant specialists. They can only eat particular plants. Why is that? Well, plants have made them specialized. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense. It keeps most of the insects of the world from eating most of the plants of the world, which is why it's green out there in the summertime. It's not because there's no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. There's a reason it's hard to get our kids to eat their vegetables. They inherently know they're toxic. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? That's where the specialization comes in. 90% of the insects that eat plants are host plant specialists, just like that monarch. They can only eat the plants for which they have specialized adaptations that circumvent, that help them get around all those chemical defenses. Specialized enzymes that store and excrete and detoxify those compounds, behavioral adaptations and life history adaptations that minimize their exposure to those compounds. But it takes a long period of evolutionary history with all those plant lineages for those adaptations to fall into place. And once they do, the insect's locked into eating that particular plant. So if you take the milkweeds out of your yard and replace them with hostas, the monarch's not going to start to make a living on hostas. It is locked into milkweeds and has two choices: fly away and find milkweed someplace else, or starve to death. Turns out there's three kinds of plants out there: plants that contribute energy to local food web, plants that do not contribute energy to local food webs, and plants that remove energy from local food webs. The very best contributor around in 84% of the counties in which they occur is one of the oaks, genus Quercus. They are conserving more energy to local food webs than any other plant genus by far. Good example of a non-contributor would be a ginkgo, Ginkgo biloba from Asia. It's a good ornamental plant, has good fall color, but nothing eats a ginkgo. So it's not adding any energy to the local food web. And a good example of a detractor would be any of our invasive ornamentals. Not only, remember, they're all from different continents, so they're not adding any energy to the local food web, or very little, but they are escaping from where we plant them and becoming major invasive species, pushing out the contributing native plants that do support the local food web. So the end result is they have removed energy from the local food web. So all I'm trying to say here is that plant choice matters. We are not going to be able to rebuild ecosystems if we don't have functional food webs in those ecosystems, and we're not going to have functional food webs unless we use the right plants. And I'm going to give you 3 examples of how well this works when we do choose the right plants, starting with my house, our house. My wife lives there too. In Oxford, Pennsylvania. This is what it looked like when we moved in the year 2000. It was a farm, a real farm, and farmed 300 years. They sold it, broke it up into 10-acre lots, and we got one of those lots. And last thing it did was mow it for hay. So there was very little there other than invasive species when we moved in. And our job was to put it back together again, which we had never done before. We really didn't know what we were doing. But one of the things I wanted to just see is, if I planted a caterpillar's host plant, would that caterpillar come and start to make a living at our house? And the first one I tried was the Canadian aloe. I'd never seen a Canadian aloe. It's a cute little thing. People say, why'd you choose a Canadian aloe? I looked through Dave Wagner's Caterpillars of Eastern North America, and I said, that's a pretty one. That's what the adult looks like, just like a leaf. Well, you're not going to have Canadian aloes unless you have their host plant. Their host plant is meadow rue, host plant specialization. We didn't have any meadow rue. I'm sure it was there 300 years ago before they farmed it to death, but meadow rue long gone. So I got some seeds from someplace, planted them. They grew very nicely. But this was early on, and I actually had very little faith that Canadian aloes would appear out of nowhere and find my little patch of meadow rue. So I didn't even go out and check it for at least 2 months after I planted it. And I was walking by for another reason, and looked over, it's covered with Canadian aloes. They had found it right away. I'm still impressed with that. So now we have a good population of meadow rue and Canadian aloes. We've added 2 species to the property. The restoration has begun. Same story with the goldenrod stowaway. That beetle moth, that's actually a misnomer, has nothing to do with goldenrod. It's a specialist on that plant, Biden's aristosa, bitch daisy. We don't have any Biden's aristosa, but I did know where there was some vines in a power line cut about 14 miles away. So I got some seeds, planted them at home. They grew very nicely. As a matter of fact, last year they took over my front yard. That's okay. I had to wait a year for the goldenrod stowaway to find my patch of Bidens, but they did, and now we have a good population of both of those. So we've added 4 species to the property. Want to see if the hackberry emperor would make a living at our house. Not because it's the most beautiful butterfly in the world, but because it belongs there. It's one of the species that ought to be there, but as its name suggests, it's a specialist on hackberry, on celtis. We didn't have any hackberry. So I planted hackberry, a couple trees. I had to wait 4 years for the hackberry emperor to find my hackberry, but they did. And now we have a good population of those. So we've added 6 species, and that's how the restoration proceeded. We did not plant goldenrod, came in on its own, and along with it came many of the things that use goldenrod, like the brown-hooded owlet, the Arsidra flower moth, the goldenrod leaf miner, the distinct Sparaginophis, the goldenrod gall moth. There are 110 species of moths that use goldenrod in the mid-Atlantic states. I planted Virginia creeper. Yes, Virginia creeper. I hear some of you don't like it. It's a great native plant. It's got good fall color. It's a good ground cover. It can climb our trees without girdling them, without pulling them down. It makes valuable berries for the birds in the fall. And by valuable, I mean they are high in fat. Remember, our migrating birds need sources of fat to fuel that migration. And our overwintering birds need sources of fat to help them get through the winter. And those berries come from tiny little inconspicuous flowers. You don't even know when Virginia creeper's in bloom until you see this big cloud of native bees around it. Turns out it's a wonderful pollinator plant. So remember, when you're making a pollinator garden, you're making it for the pollinators. If it's not big and showy for you, that's okay. I planted Virginia creeper because it's the best host plant for the large sphinx moths that are a primary component of cardinal diets. Things like the Pandora sphinx and its beautiful adult, the lettered sphinx, the hog sphinx, the abbot sphinx, all on Virginia creeper. Want to see if I get the double-toothed prominent to make a living in our house, just because it's such a cool-looking caterpillar. Looks like a stegosaurus. Even if you don't like caterpillars, you got to like this guy. It's a specialist on elm, particularly American elm. We didn't have any American elm. Of course, we lost it decades ago to Dutch elm disease. But there are 2 big American elms at the University of Delaware that did not die. And every year they make a lot of seed. So the second year after we moved in, I gathered up some of those seeds from the gutter, planted them. They germinate in 6 days, grow very quickly. Today, those trees are over 80 feet tall. And yes, they brought in the double-toothed prominent, another big success, American elm. Want to see if I get the evening primrose moth to make a living in our house because it's beautiful. I like beauty like anybody else. Well, as its name suggests, it needs evening primrose, and we didn't have any, so I planted it. The moth did come, spends the day with its head stuffed in the flowers. Sometimes it's crowded in there, but it's always very cute. And I planted lots of oak trees. Now, these are just examples of the plant lineages we put back on our property, but I want to focus on oaks for a while because they are such important plants. That's the Bedford oak in Bedford, New York. People argue about, that's Martha Stewart land, by the way. They argue about whether it's 400 years old or 500 years old. It's enormous. And I hear people say, I'm not going to plant an oak because I won't live long enough to enjoy it. And if you can only enjoy your oak when it's 400 years old, you're right, it won't. But if you can enjoy what your oak is contributing to your local food web, you can enjoy it right away. And I can say that with confidence because I planted most of my oaks as acorns, which means they were free, or 2-foot barewood whips, which means they cost $1.50 each. And immediately they started to call in the moths that create the caterpillars that run the food web at my house. Things like the solitary oak leaf miner, Juvenil's dusky wing, the yellow-shouldered moth, the Suzuki's promelampus, the red wash caterpillar, the yellow-vested moth, the orange-tufted onidid, the spiny oak caterpillar, the 2-spotted oak punky, the variable oak leaf caterpillar, the red-humped oakworm, the pink-striped oakworm, the hesitant dagger moth, the lesser oak dagger moth, the medium dagger moth, the greater oak dagger moth, the streaked dagger moth, the afflicted dagger moth, the crown bucolatrix, the orange-patched smoky wing, the white-blotched heterocampa, the oblique heterocampa, the red-lined panapoda, the laugher, and literally hundreds more caterpillars have come to the oaks on our property, and they come right away. I clap for oaks too. They're just the best. But look, There's a caterpillar standing on the ground eating the seeds of this pinnate right after it germinated. You don't have to wait decades or hundreds of years for your oaks to start to support your local food web. They will do it right away. Now, this is what our house looks like, taken from pretty much the same place I took that first picture. Just to give you an idea, we put some of the plants back, still working on it. But my research has shown over the years that if you know the number of species of moths in your local food web, moths, not butterflies. Butterflies are bad tasting, day flying moths. They really are. And because they taste bad, which is why they can fly during the day, the birds really don't like them very much. So they're not contributing a lot of energy to our local food webs. But the moths are. So if you know the number of species of moths in your local food web, you have a very good index of how stable that food web is and how productive it is. How many species is it supporting? So for the last 7 years now, I have been counting the number of species of moths that make a living at our house. And by counting, I mean taking a picture of them. And I am still at it, but I'm up to 1,266 species that I have pictures of, and I'll be happy to show you that PowerPoint if you don't believe me. Now, Pennsylvania is what, 29.2 million acres? We've got 10 acres. So in one tiny, tiny, tiny slip of Pennsylvania, we've got 48% of all the moths that occur in the entire state because we put the plants back. And because so many of these are types of bird food, we have recorded 62 species of birds that have bred on our 10 acres, not flew by, but bred. Why am I telling you this? This is another headline we see all the time. The World Wildlife Fund says the Earth has lost 2/3 of its wildlife since 1970. It's a terrible statistic. I'm thinking, gee, not at our house. We have increased biodiversity by more than 2/3. It didn't take that long, and it wasn't that hard. We just put the plants back. What would happen if everybody put the plants back? We really could put a dent in some of these terrible headlines. But a good question is, will it work on smaller properties? Not everybody has 10 acres. Will it work in suburbia? It's a great question. So let's go to Margay and Dan Terpster's house in Kirkwood, Missouri. They have 0.6 acres, 18 times less land than Cindy and I have. They're in the middle of a development. Everybody else has the big lawns. When they moved in, their yard was choked with bush honeysuckle, Amur honeysuckle, another invasive from Asia. So they got rid of that. They planted 70 species of native plants, put in a water feature that they call a bubbler. And then they started to count the birds using their yard. They are up to 154 bird species, including 35 warbler species that have used their yard, an incredible number. We've only recorded 8 warbler species at our house. So does it work on smaller properties? Absolutely. What about urban yards? Let's go to Pam Carlson's house in Chicago. And I mean in Chicago, her house abuts, her property abuts O'Hare Airport. She has 1/10 of an acre. 3 times smaller than the average lot size in North America. She's not connected to any natural area at all. So she is a tiny island. It's a pretty island because Pam's a native plant landscaper. Everything you see there except the grass is a native plant. So next time somebody says you cannot make a pretty landscape out of native plants, remember Pam's yard here. But she did the same thing. She got rid of her non-native plants, put in 60 species of native plants, a water feature, and then she started to count the birds using her yard. And she's up to 125 bird species that have used her 1/10 of an acre, including a woodcock. There's Pam's woodcock. So if you haven't seen woodcock lately, go to Pam's house in Chicago. All right, there's 4 things we need to think about if we're going to succeed in a big way, and we want to succeed in a big way. And one of them is we've got to reduce the area that's in lawn. Latest figure I saw was 44 million acres of lawn. It's going up. It's not going down. Which is an area bigger than all of New England combined, dedicated to an ecological deadscape. Why do we do that? Well, it's a status symbol. It's an important status symbol, and we have to display our Halloween decorations and our Christmas decorations. But what if we cut the area of lawn in half? Notice I'm not saying get rid of lawn, just cut the area in half. It still is the perfect plant to walk on. It's a great cue for care, shows that we understand the culture, but 44 million acres, let's cut that area in half. Let's take spaces like this and turn them into this. I got this picture from Dan Getman. I never met Dan, but he lives in Missouri. He had that big lawn, and he said, look, I'm putting the plants back. He sent me this picture. Well, let's make the math simple. Let's say we've got 40 million acres of lawn. We're going to cut that in half. That'll give us 20 million acres we can put towards restoration right at home, which is enough to make homegrown national park. And it'll be big. It'll be bigger than the Adirondacks. plus Yellowstone, plus Yosemite, Grand Tetons, Canyon Lines, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, plus Denali, which is huge, plus the Great Smoky Mountains. Add up all those parks, still less than 20 million acres. So Homegrown National Park will be the biggest park in the country. What do we get when we put a park at home? What do we get when we put some part of nature right where we live? We get the opportunity to interact with that part of nature. At our own time, our own pace, all we have to do is go outside, or maybe even just look out the window. We can avoid crowds. You know, if you go to a real national park, 375 million people there, that was the figure last year. I know what you're really going to interact with. It's free, there's no admission fee. It's never closed, no matter what pandemic or government closure comes down the pike. No travel hassles. You get to experience the natural world alone, which I think is essential to developing that personal relationship, that unique relationship between you and Mother Nature, not mediated by somebody else. And it's particularly important for our poor kids who are suffering from nature deficit disorder, according to Richard Louv. So we're trying, we get 30 kids, we put them on a bus with a teacher, they drive for an hour to a natural area. They walk around for an hour, teacher tells them not to touch anything. They get back on the bus and they go home, and that's their experience with the natural world, which I'm sure is better than nothing. But it's really been an experience with 30 other kids and a teacher telling them not to touch anything. If they have some part of nature right where they live, all they have to do is go outside and get to know it, explore it, become friends with it, fall in love with it. Alone, no parental supervision. When we hover over our kids, we are sending the message that this is dangerous stuff. You are not capable of dealing with this yourself. That's a terrible message to be sending to the future stewards of the planet. If they're afraid of Earth stewardship, if they don't know what it is, if they don't love it, they're going to be lousy stewards. We don't need any more lousy stewardship. And maybe they'll learn how to hunt lizards. I'm learning this from my own granddaughter, Zoe, who lives in Hawaii on a very modest patch of nature. It's a piece of lawn with a hedge, but there are anole lizards there. And when she discovered that, she sent me this picture to describe how you hunt lizards. You get on the ground and you cover yourself with leaves and sticks so the lizards can't see you come. Then you crawl very slowly towards the lizard. No smiling, this is serious business. You can wear your best dress, that's okay. But you sneak up on the lizard, you catch the lizard, you put it in an aquarium, you learn how to take care of that lizard. You become a good steward of that lizard. Now, I don't think Zoe's going to be crawling on the ground in her best dress, catching lizards the rest of her life. I don't think. She sent me this picture, so I don't know. But I guarantee she's going to remember these interactions with nature the rest of her life. And I guarantee she will be a good steward of the planet. And Homegrown National Park, it's a real thing. We've got a small nonprofit now. You can go to our website, homegrownnationalpark.org, and register your property on the map. That means you're going to put your location where you are and the amount of area you're going to be a good steward of. It's kind of like a pledge. We don't expect you to be finished. Maybe you really are going to reduce the area of lawn. Maybe you're going to plant an oak tree. Maybe you're going to put an aster in a flower pot. It doesn't matter how small it is. When you enter that into the data set, your little piece of your county is going to light up with a firefly. You get to see who else in your county has joined Homegrown National Park, at least how many other people. We want the whole country to light up. So that's the goal, is to get this message that we're all responsible for good earth stewardship to go viral. The states are color coded depending on participation. So the darker green your state is, the more people have joined. What's our mission? To regenerate biodiversity by motivating millions of people to plant those native plants that are supporting biodiversity, remove the non-native plants that are not supporting biodiversity, and in doing so, reshape their relationship with nature. Did I mention it's free? We're not trying to pull membership away from Audubon or National Wildlife Federation or anything else, but everybody, you guys are doing such good conservation on private property. We want it all recorded on the map. What are our ecological products? Significant increase in biodiversity. And what's happened on my property at home shows just how resilient nature is. There was very little there when we moved in, and there's a lot there right now. Measurable reduction in invasive species. If everybody got rid of the invasive species just on their property, we'd be 78% done. We'd be 85% done in the east. That's a very good first step. Significant drawdown of atmospheric CO2. Lawn is the worst plant choice for sequestering carbon. If you replace it with anything else, you're going to help climate change. And you're going to start to build viable habitat outside of parks and preserves. Any bit of habitat we have, or any bit of conservation we do outside of a park is going to help conservation inside of the park. There are equally important sociological products here. National awareness, not just of what the problems are, but what the solutions are and what our roles in those solutions are. We really are trying to change the culture. We want people to recognize that nature's not just there for our entertainment. It's essential. It's essential for each one of us. And that means each one of us needs to play a role in sustaining it. We want to convert hope into action. Hope is good, but action's even better. And we do want to merge all of the good conservation that's happening at Audubon, National Wildlife Federation, Sierra Club, all the land conservancies, all the stuff that's happening on private property. We want to get recorded on that biodiversity map so we can see where there's gaps. We can see how well we're doing towards that 30 by 30 initiative. Remember that? We're going to save 30% of the US by 2030. Not if we don't record conservation on private property. So we're going to shrink the lawn. What plants should we put in the area that was once lawn? I'm going to argue that some of them have to be what I'm calling keystone plants. Remember what a keystone is? It's the stone in the middle of the Roman arch. And if you take that stone out of the arch collapses. Well, if you take keystone plants out of the local food web, the food web collapses because they are making most of the food. Just 14% of our native plants are making 90% of the caterpillar food that drives those food webs. So think of the keystone plants in the ecological house that you're building as the 2x4s that hold that house up. They are the support system. You cannot build a house out of wallpaper. And that's what we've been trying to do for the last century. What's the best keystone plant? Again, it's one of the oaks in 84% of the counties in which they occur. They support more than 557 species of caterpillars in the mid-Atlantic states. Compare that to tulip tree. Tulip trees are good trees, but they only support 21. There are huge differences among our native plants. Oaks support more than 950 species nationwide. No other plant genus comes close to that. If you want to find out what the best plants are where you live, you go to Native Plant Finder on National Wildlife Federation website, put in your zip code, and the ranked list of the most important woody plant genera and herbaceous plant genera in your county will pop up. And the lists are much bigger than this. That's just, I ran out of room. So the old excuse of I don't know what to plant is just an excuse now. Go to Native Plant Finder and you do know what to plant. So we're going to shrink the lawn. We're going to use keystone plants. We're going to invite a lot of insects to our yard, and then we're going to kill them with our security light, which is not the goal. Light pollution, it turns out, is one of the major causes of insect declines around the country. Those are all the ways that lights are killing our insects, particularly the moths that create those caterpillars that run our food web. This is good news to me. It's good news because we've got to turn around, not just stop, but turn around insect decline. As of 2014, we had lost 45% of the insects on the planet. The latest figure I saw was 75%. We are not going in the right direction. If we can turn that around by flicking a switch, we're getting off easy. There are a lot of switches to flick, but there's a lot of us out there to flick those switches. And somebody's going to say, well, I can't turn the light out over my barn or my garage or my front porch because the bad man will come. All right, put a motion sensor on your light so that it only turns on when the bad man does come. And the first thing you notice is the bad man does not come very often. And if you don't want to do that, take the white bulb out of your security light and put in a yellow bulb. Yellow wavelengths do not attract nocturnal insects. It's the easiest fix. If we were to switch out our white bulbs for yellow bulbs overnight, we could save millions of insects. And if we use LEDs, we could save millions of dollars too. So we're going to shrink the lawn. We're going to use keystone plants. We're going to modify our light system. Then we're going to invite the mosquito foggers to come kill all of our insects. Booming business around the country. And they say, it's okay. What we are fogging is an organic, natural product. And it is. It's pyrethroids made by chrysanthemums to kill insects. So it's organic and natural, just like cyanide, just like ricin, just like nicotine. There's a lot of organic natural products out there that aren't quite as warm and fuzzy as they would have you believe. They also say it only kills mosquitoes. Not so. Kills all the insects it comes in contact with. This is the result of a mosquito fogging event on Kent Island in the Chesapeake a few years ago. My friend happened to be there and he picked up a handful of dead monarchs, but he said there were thousands on the ground. It was during a big migration event. It kills all the pollinators that we're trying to save. The interesting thing is it does not control mosquitoes. You can't go control mosquitoes in the adult stage. It's too hard. You have to kill 90% of them to get good control. These guys kill between 10 and 50%, which is why they have to keep coming back and killing your monarchs and pollinators over and over again. If you really want to control mosquitoes, try biocontrol with mosquito dunks. Get a bucket and fill it full of water and put in a handful of straw or hay or maybe some dead leaves. Put it out in the sun for a few days. That will build up populations of diatoms and algae. And that is what mosquito larvae eat. So this becomes an irresistible brew to any female mosquito in your yard. She will lay her eggs in your bucket, preferentially. Then you go to the hardware store and you buy a sheet of mosquito dunks, $12 for a season's worth of control. That is Bacillus thuringiensis, a natural bacterium that only kills aquatic diptera. And the only aquatic diptera in your bucket is a mosquito larva. So it's targeted, it's cheap, and if everybody did it, it would be effective. This is effective too, by the way. Get a fan, plug it in, put it on your picnic table. You can sit and have a drink in the directed breeze. Mosquitoes don't fly into that. So you can enjoy your yard without killing anything. All right, the fourth thing we need to do to encourage, to improve the survivorship of caterpillar populations is to change the way we landscape, particularly under trees. Now, this is just an example. I live in Chester County, Pennsylvania, where oaks support 511 species of caterpillars. A few of them, like the polyphemus moth, complete their development on the tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from one of the branches, then it emerges as an adult, then it does it all over again. Everything happens on the tree, but that's the exception. Most species finish growing as caterpillars on the tree, and then they drop from the tree and wiggle their way underneath the ground and pupate underground, or they spin a cocoon in the leaf litter that's under the tree. And that's the problem. There is no leaf litter under the tree. We don't tolerate it. It's messy. And we mow and compact areas around the tree so that it's rock hard. So when the caterpillars drop down, particularly in the summertime, they can't get underground. And this becomes an ecological trap. I'm convinced that the way we landscape under our trees is another major cause of insect declines around the country. And of course, the cement landscape is not the answer either. So what most people do, you got a tree in a yard. I've got a grad student, Emma Jonas, measuring how well caterpillars do in a situation like that. But I guarantee they do better in a layered landscape like this. It's a soft landing. Caterpillars fall out of the tree. The soil is not compacted. There is leaf litter underneath there. They have everything they need to complete their development and have high survivorship. This is where you can do your fancy spring ephemeral gardening. This is how you shrink the lawn, put big beds under all of your trees. The more beds you put under trees, the less lawn you have. Your tree will love it, and so will those caterpillars. Use the native ground covers we have liberally. Things like wild ginger, native pachysandra. There's Virginia creeper as a ground cover. Golden seal, mayapple, foamflower, ferns. If you can see the ground, you don't have enough plants. Green mulch is the way to go. Your tree will love it, and so will those caterpillars. Former grad student Desiree Narango did some wonderful work with chickadees in the suburbs of Washington, D.C., and her results suggest there's room for compromise in our plant choices. And compromise, believe it or not, is okay. She had one simple question: how will the chickadees do in suburban landscapes that are dominated by native plants versus landscapes dominated by traditional non-native ornamentals? And when they're dominated by non-native ornamentals, they produce 75% fewer caterpillars. So right away, you reduce the amount of bird seed, the amount of bird food by 75%. They were 60% less likely to have breeding chickadees at all. Every landscape had a nest box up in it, but the chickadees would come and look around and say, there's not enough food here. We're not even going to try to reproduce. If they did try to reproduce, those nests contained 1.5 fewer eggs. Those clutches were 29% less likely to survive. If they did survive, they produced 1.2 fewer fledglings, and it took them 1.5 days longer to do that. And if you put all that into a population growth model as a function of the percentage of non-native woody plant biomass in your yard, from 0 to 100%, this is what you get. We looked at woody plants because that's where chickadees forage, on woody plants. That dotted line in the middle there is replacement rate. That's the rate at which the population has to make babies to replace the adults that die every year. If you reproduce at that rate, you have a sustainable population. It's not growing, but it's not shrinking either. If you make more babies than adults die, anything above the line, then you have a growing population. And that's what happens when you have very few non-native plants there. But if you're below the line, which is what happens when you have a whole bunch of native plants, then you have an unsustainable declining population. In the middle there, you see where those lines intersect. That's the area of compromise. It suggests we can have up to 30% of our non-native woody plant biomass, or of our woody plant biomass non-native, without destroying the local food web. We cannot tolerate any invasives, no calorie pear, no burning bush, none of the things that we know are going to escape and become ecological tumors. But there are a lot of ornamentals that are not invasives. Back to Dan Getman, that's a ginkgo tree. Did you pick that up the first time? Why does Dan have a ginkgo in his native planting? Because Dan's wife likes ginkgos, and Dan likes his wife. So he put the ginkgo in. The question is that plant going to destroy the productivity of that landscape? No, it's not. It's just there. Is it going to escape and become an invasive species? No, not ginkgos. It's just there. So I like to think of plants that are just there, not really contributing, as if they are statues. So there you go. There's Dan's statue. If all of Dan's plants were statues, he would not have a productive landscape. But it's not the presence of those non-native plants that destroys food webs. It's the absence of the highly productive native plants that support them. If we increase the percentage of those, we can tolerate some of the non-natives. Can we use native plants in formal designs? Of course we can. This is a Lynn O'Shaughnessy design taken by a drone 400 feet up. You do not get more formal than that, and every plant in that landscape is a native plant. Formality is a function of the design. It's not a function of the plants in the design. Our native plants are used in formal designs in Europe every day. They love them over there. If Europeans can love our native plants, maybe we can too. Can we get a pollinator garden into a typical suburban yard like this without offending anybody? Of course we can. Put a little fence around it. It formalizes it. It tells your neighbor it's not just a bunch of weeds you forgot to mow. It's pretty when it's in bloom. It's meeting the needs of several species of bees. It's not very big, could be bigger, but if everybody did it, it would help a lot. Help what? Help make pollinators. Why do we need pollinators? Well, the media will say because they pollinate a third of our crops, as if that's the only reason we need pollinators. It's not even right. They pollinate about 1/12 of our crops. And I hear people say, well, I don't live next to a farm, so I don't need any pollinators. Forget the crop argument. We need pollinators, and we need pollinators everywhere we need plants because they're pollinating 80% of all those plants and 90% of the flowering plants. How about this Drew Latham design? It's much bigger. Imagine the amount of life in that bed versus the amount of life in the lawn next to it. Seems like a no-brainer. Can municipalities help us live with nature? Yes, they can, and more of them are doing it. Minnesota has a cost-sharing plan that encourages homeowners to replace some or all of their lawn with appropriate Minnesota prairie plants. It's very popular. Pennsylvania has a new program like that. Virginia's starting one. It's really starting to catch on. There's an island off of Florida, I think it's Marco Island, that is paying homeowners to allow burrowing owls, listed species, to burrow in the front yard. This is the way the Endangered Species Act should have been written, with carrots rather than sticks. If you have an endangered species on your property, we're going to pay you to take care of it rather than fine you if you use your property. Everybody would want an endangered species. Put a bounty on these invasive ornamentals like calorie pear. That's what St. Louis, Missouri did, Fayetteville, Arkansas, North Carolina. You take out a calorie pear, you get a free tree replacement. Water utilities giving people $100 coupons to plant water efficient native plants. And of course, the big lawn reduction programs in California and other areas in the West. That's going up. You get $3 rebate for every square foot of lawn you replace with a xeric planting now. California does not have one drop of rain to waste on grass. And if you want more information on any of those programs, memorize them. All right, I think we made 3 missteps in the early years of conservation. And the first one's important. We're starting to think of nature as if it's optional. We like nature. It's not that we don't like it. We like to go bird watching. We like to ride our bikes or just sit and watch it. But it's not essential. And if it's not essential, when push comes to shove, when resources are in short supply, which is always, nature takes a back seat. I went to the Cincinnati Zoo before the virus broke out, and there's this wall-sized poster there, which to me epitomizes our society's view of conservation. We want to save nature, we want to save wildlife so that future generations can enjoy it. That was Teddy Roosevelt's argument for expanding the national park system. They're beautiful places, we want to save them so that future generations can enjoy them. And I get that, because nature is enormously entertaining, but it is much more than that. We need to save nature so that we have future generations. It's a little bit more urgent. We've also seen that humans and nature cannot coexist. And we talked about that. But if we restrict conservation just to the places where there's not a lot of humans, we're going to fail, because those places are too small, too few, and too isolated. David Quammen has a great analogy between a Persian rug and an ecosystem. That is a functional Persian rug. That is not 71 Persian rugs. That's 71 rug fragments, none of which are acting like a Persian rug, and that's what we've done to our ecosystems. The UN designates biosphere reserves as places of ecological significance. I don't like that language because it suggests there's places on planet Earth with no ecological significance at all. Not so. Every square inch of the planet has ecological significance, and we have to start thinking of it that way. That includes our yards, that includes our corporate landscapes, it includes our campuses, it includes our roadsides, it even includes much of agriculture. So we need to glue our rug back together again, folks. Got to put the plants back. Not just to make biological corridors that connect viable habitat with each other, but to recreate viable habitat in those places where we've destroyed. The good news is it's starting to happen. It really is starting to happen. And when it does, it'll be the first time in modern history that we humans have coexisted with the natural world. Our third misstep was to leave Earth stewardship to just a few specialists, a few conservation biologists, a few ecologists. For some reason, we didn't see it as an inherent responsibility of everybody on the planet, but I don't know why, since every single person on the planet depends entirely on the quality of local ecosystems. So why wouldn't everybody bear the responsibility of taking care of those ecosystems? Stan Rushworth, the Cherokee elder, once said, the Western settler mindset was, I have rights. The mindset of indigenous people is, I have obligations. You're not born with those mindsets, you are taught them. We've been very good at teaching our kids about the rights that they have. We've been terrible at teaching them and our peers about their obligations to good Earth stewardship. That does not mean you have to save biodiversity for a living, but you can save it where you live. And if you do, it empowers you. There are more and more people that recognize the Earth has got some serious issues, but they feel powerless. What can one person do? Well, one person can shrink the lawn, one person can use keystone plants, one person can fire Mosquito Joe, one person can put in a pollinator garden, one person can turn out the lights or modify the light system. There's a whole bunch of things that a single person can do to revitalize the little ecosystem on their property and then enhance their greater local ecosystem instead of continuing to degrade it. And it shrinks the problem down to something that's manageable. Don't worry about the entire planet's problems. You'll get depressed. Just worry about the piece of the Earth that you can influence. If you own property, it's obvious. That's where you start. If you don't own property, help somebody who does. Help a land conservancy, help a park or preserve. They're all underfunded, they're all understaffed, they will love you as a volunteer. So as a property owner or a volunteer, each one of us has the power, and we certainly have the responsibility to fix dead landscapes like this. Whether or not we do so is going to determine nature's fate and then ultimately our own. I think I've convinced my grandchildren that you are nature's best hope. I hope I've convinced you as well. And I will leave you with those websites in case you want to copy them down. Thanks very much.